Great. Hey everybody, good evening. Welcome back. It's Monday night. It's nice and summery out. Hope everybody had a great long weekend. Well, although I don't know, you're in classes, I don't know how long your weekend was. Probably had homework and stuff to do, like for this course. But I appreciate everybody joining, whether you're here in the classroom or whether you're online. This week we'll be talking about pair programming. So here's what you can expect. Tonight. We're going to talk about pairing and sort of get a review. I hope you had a chance to watch the screencast for it. I'll highlight a couple of things tonight, but other than watching a kind of a cheesy old video about pair programming, I hope you take in the lecture to understand some of the nuances, what the roles are all about, things like that. We'll also be talking about Project 2 tonight. We'll assign that tonight. So exciting night tonight. Got stuff to cover. Oh, and we'll also be doing an activity where I'll be pairing with brave volunteers from the classroom, and so then so we can see sort of what pairing is like in practice. And then on Wednesday, everybody's going to be pairing. So Wednesday is the first night that everybody is required to be here in the classroom. So please plan accordingly to make sure that you can get down to campus for a punctual 6 p.m. start time. And we'll be pairing up. So please bring your laptop. Bring an HDMI adapter if you want to use one of the projectors around the room. I'm looking forward to that. That'll be good. Oh, and note also on Wednesday, the first project, the koans are due. Yeah, we'll have a good time on Wednesday. Before we dive into things for tonight, I wanted to open up for Prime Minister's questions. I want to check in with everybody, see how it's going. I've seen a couple people who have submitted their koans already. Thanks for doing that to help me make sure that my grading script works okay and everything. But what else can I tell you? How are the koans going? Anything that you'd like to know about that? Project 1? Okay. Yeah. Oh, interesting. So, okay, yeah, so you're editing in IntelliJ, right, IntelliJ, yep. And so as you're changing the files, they turn blue. I think that means there's a local modification, which makes sense, right? So you change them, and so then you committed them all to GitHub and did all that, right? But you said 2 of them didn't change. Are they ones were they ones that you had already modified and did you need to modify them again, or? Yeah. Oh, interesting. They're still showing up as blue. Okay. Well, when you look at either the commit, and actually I'll show you there. So either the commit view here, if you see something there, well, it means you've got a local modification. If that doesn't show anything, you can go to the command line and run git status. And if git status says there's no changes, then I don't know, IntelliJ is confused and thinks there's a change when there actually isn't. So I mean, ultimately the test is going to be, hey, listen, when you get a checkout of when we pull your latest changes up on the PSU machine, if you run the Maven exec :Java, and if it says great, all 267 or whatever, if it says they're all passing, then you're good. So you can submit. Yeah, no, awesome. Most people like to know. Let's see here. Oh yeah, question from the chat. For plan of attack, we should describe how we have implemented the project in overview level. Am I right? Yes. Even more ideally, and actually, yeah, I suppose the plan of attack was due on Sunday. I forgot to remind people about that. Oh, no, there's not a plan of attack for koans. Never mind. For the plan of attack, I know, yeah, right. Sorry. For the plan of attack, well, you should describe how you will implement it. I mean, ideally, you're supposed to write the plan of attack before you implement it, but I mean, I can't really force that. So yes, the whole idea is, and there are lots more details in the how to document your projects handout. The whole idea here is that the plan of attack is a brief description of what you're going to do, how you're going to implement. Like, what are some of the things that are on your mind? What are you thinking about? What things might be tricky? What things you want to make sure you get right? What informs your test strategy? All sorts of good stuff like that. Let's see here, with project 1 being due next Wednesday, right? 16th? Yep. Highly encourage you to to get started on it, or at least make sure you've created it. You can build it in IntelliJ. You can work with it, and make sure that you can get off the ground that way. And then hope you're finishing off the koans and getting a head start. Getting started on project 1 because as I noted, project 2 is being assigned tonight, and the project's kind of come fast and furious. It's going to be 1 per week, and so then want to make sure to stay caught up and everything. Okay. Anything else you'd like to know before we dive into pairing? Okay, so I've got a handout to talk through tonight. I posted it in the Slack. I also posted here in the Zoom chat. Handout for tonight, and it's all about pairing. So, like I said, the theme for this week is pair programming. It's what we're going to learn about, and when I demonstrate pair programming, I'm going to use test-driven development. I encourage you to do the same in your own pairing. And we're going to be working on what's called code katas. I think I mentioned this before. These are little programming exercises that are certainly more complex than the koans. But the whole idea is it's a little exercise for people to not necessarily it's not about solving the problem, it's about how you solve the problem. It's good for exploring things like test-driven development or working with other people or refactoring. They're meant to be little teaching exercises, but bigger than a koan, but not as big as your assignments per se. So what we'll do tonight is talk about pair programming and what pairing is all about. Really, I want to show and I want us to experience what pairing is. And so what we'll do is we'll work through a little a kata called Fizz Buzz, which you might have heard of before. It's super simple, and that's okay because it's not so much about, again, solving the problem as it is learning how to pair. And then on Wednesday, we'll spend an hour or so on a simple kata called leap year. Again, which is help you learn about pairing and do test-driven development, work with somebody else. That's when you will all be pairing. And then the following Wednesday, we'll do our second pairing activity. Again, this Wednesday is in person. The following Wednesday, you can be in person or remote. Both are perfectly valid, and it's a good way to get experience. But I have found that people appreciate and understand, have much better expectations for remote pairing once they've done an in-person one. So that's kind of what we'll be doing this tonight, tomorrow, and next Wednesday, or this coming Wednesday and then the Wednesday after. So for all of our katas, we'll be using the same GitHub repository. When I first started doing this, I had students set up their own, basically make another copy of Getting Started repository and do all of that. It took forever. It blew away too much time. And so what I've been doing recently is having us all share one repository, which actually makes things more efficient, and it also gives us all really practical experience in having multiple people all committing to a repository at the same time. So it's a good skill to have. I posted about this over the weekend, and so thanks to everybody who got a head start on it. Here's what I'd like you to do. So, please, tonight if possible, sort of during class, if you would, make a clone of this repository in your, on your development machine. So, clone it from GitHub, and make sure that you can open it and look for this I can edit this repo file. So actually, I'll just show you right here. Let's see here. I've got checkout of the kata's repository right here. So I'm going to navigate, and it's the top level here, to a file called I can edit this repo.txt. And what I'd like you to, and by the way, if I had your GitHub ID, which I think I have for almost everybody, I sent you an invitation to be a collaborator on this repository. So by default, not just anybody can commit and push to a GitHub repository. You need to have permission to do so. You need to be granted access. You need to be made a collaborator on that repository. And I believe I've invited everybody to be a collaborator, so please check your email and accept the invitation if you haven't already. And that should give you the ability to push this repository. And the way we're going to validate that is the following. So please open up this I can edit this repo.txt file and look for your initials here. So this is first name, last name, and it's in alphabetical order by last name. Find your initials and delete the initials and replace it with the word here, commit, and then attempt to push to the GitHub repository. If you are unable to push the GitHub repository, please let me know. Send me a DM in Slack, or IM me on the meeting chat, and I don't know, maybe a break or at some point maybe we can do it in real time. I'll make sure that you've got an invitation to be a collaborator. This is a really important first step. This makes sure that everybody has the ability to push. Otherwise, if we don't validate it tonight, then it'll really disrupt your pair programming on Wednesday. You'll be unable to push, and then you and your partner will be impeded in your ability to share your code. Because what we're going to do is we're going to use the GitHub repository to share our code when pairing. It works really well, especially when you're remote in the second time, in the second go round of pairing. But it also makes it so that we don't have to touch each other's keyboards and things like that. Because especially I know I'm so sensitive to making sure that germs don't spread. So while I'm talking about pairing, if it's something that you could do in the background, that'd be great. Or if you really want to pay attention to me talking, it's something that you can do after class. Although I'd appreciate if people here in the classroom can give it a try just to make sure. So again, please get yourself check out a clone of that Kata's Summer 2025 repository, and make sure that you can commit. I just want to highlight that we're very purposefully all sharing, playing all in the same pool. You're going to find, as a matter of fact, as you're modifying the I can edit this repo file, you might make your change and go to commit, and GitHub might reject the change because you don't have the latest changes down. So pull them down. You might find yourself in this little cycle of okay, get the latest changes, try to push. So get the latest changes, merge them in, try to push back. It may or may not work on the first try. That's okay. It's what we're here to learn. It's what we're here to experience. So I'm just going to just see, hey, has anybody been able to commit recently? Let's see here. Oh, cool. Looks like I did get a couple more commits here. Okay, excellent. Well, thanks for doing that. I learned this the hard way that making sure that everybody can push the repository. Doing that tonight helps the first pairing. There's lots of other things to contend with. You want to make sure that your access to the shared GitHub repository is all working fine. Okay. Oops. Oh, and speaking of IntelliJ, eagle-eyed viewers may realize that I've changed the look of my IntelliJ. Right before class, I don't know, there was oh, I need the latest Copilot plugin or something like that, and so I'm like, sure, go ahead and update yourself IntelliJ. Something went wrong, and then I think I lost all my plugins or something like that. And this made me realize that this was obviously a sign from the high lords of IntelliJ saying, hey, don't use the super old classic mode that none of you see. Start using it the way people do in the year 2025. So hopefully this layout of IntelliJ looks more like what you're using. I probably have it in light mode because I have old eyes. But hopefully the icons and everything look familiar, and so then as you watch me code is more similar to the environment that you have. Actually, is that the case? Is that the way? Is your IntelliJ laid out like this, where you have the icons instead of the words, and it's more like yours? I hope. Okay, good. Awesome. Okay. No, yeah. Did you go to the classic way, or? Yeah, no. Okay. Awesome. Okay. So yeah, let me know if anybody has issues pushing to the GitHub repository. Okay. So I want to talk a little bit about pairing and pair programming and what it's all about. I go into a lot of detail in the lecture, And so please be sure to watch that, sort of the first part of the lecture notes and the first screencast. The lecture notes cover both pairing and mobbing. We'll get to mobbing in a couple of weeks. But tonight, in this week, we're just focusing on pairing. Basically, pairing is exactly what it sounds. You have two people who are working on the same keyboard, working on the same problem at the same time. This was, a technique that evolved out of the way real people write software. And there were some people who had some observations about, like, hey, what happens when you have two people working together? What's the right amount of structure to make that that collaboration work? And people found that when you have pairing and you have test-driven development, you end up with like really high-quality code really quite quickly because you have two brains on a problem and you have two people with just naturally have different perspectives, thinking about the same problem, the same code, and so people don't get stuck. And when there is something that you solve a problem faster when you have two people that don't know the solution than you do with just one person, and just based on their knowledge and stuff. So, pair programming is more than just like two people sitting at a keyboard. There is some, like I said, some structure, some rules, some recommended ways of doing it. And here in this course, what I'd like you to experience is following the rules and see how they work for you. So we're not going to start from chaos or whatever we think pair programming is. We're going to take the sort of the well-accepted definition of it and the well-accepted structure of it and see how it works for us. So, traditionally there are two roles in pair programming. There's the driver role and the navigator role. And so the driver is the person whose hands are on the keyboard. They're the person who's typing in the code. And they think about like the structure and the syntax of the code and sort of like the very tactical thing of what comes next, like, hey, what is the next letter I need to type? Or, hey, what is the next line of code? They're not thinking so much at like the method level or the at the class level. They're thinking about just like right there and now what are they doing? That's the driver. The navigator is the other person in the pair. They're the brains, and so they observe what's happening. They're in conversation, in dialogue with the driver to take the strategic thoughts of the navigator and then convey that to the driver to implement. And these two roles are kind of the secret sauce of pairing. Because again, it's not just like everybody talking at the same time. At any given moment, there's people purposely thinking tactically, and the other person is purposely thinking strategically. Now, people don't stay in these roles forever. Every couple of minutes, you switch up, and this is a really healthy behavior for a couple of reasons. It's make sure that a person in a particular role doesn't get bored or tired or frustrated, and it cross-trains. It cross-trains people on how to approach the problem, on how to think about pairing, and how they're doing it. And so then, what I recommend and what we're going to experience is this sort of cycle of pairing, where you sit there and you pair in the two roles for several minutes, and then take a break. Or at least you put you put the keyboard down and you talk about what the experience was. So what was it like being the driver? What was it like being the navigator? What did you observe? What did you learn? What do you want to try differently for next time? And it takes a lot of discipline to do this because when the timer goes off and you got to step away. Okay, commit your code and prepare to have the next person to switch roles and have the next driver take it on or switch from being the driver to the navigator. But this little break, this little retrospective, little reflection that you do really helps the pair evolve because it takes them away from the problem at hand and lets them focus on how they're pairing, how they are collaborating together, and what's working well they want to continue and amplify, and maybe what isn't working so well that they want to try something different as they pair. So we're going to experience this. I will say that when the new driver takes over, or the new navigator takes over, they should resist the temptation to just like start over again. Unless both pairs really agree that the previous code that was written is no good. Nah, let it evolve. It'll be a good way to a good learning experience, and I think it will help the pair better understand how to work together going forward. So there are a couple of things I want to highlight about pairing. Um, there have been a couple of patterns that people have found to be effective. The first is called strong style pairing, and this is good when you've got someone who's more experienced and someone who is less experienced in the problem or the technology or whatever. Where there's really is sort of there's not a they're at different levels of understanding or capability. Um, now, in this case, it is not watching someone else code. So it's not like, oh look, here's the expert and I'm just watching them code. It's more like, okay, they're still in that dialogue, but that you acknowledge that yeah, there is a knowledge difference, capability difference between the, uh, the the two. And so in this case, it's really important for the person who's navigating to speak at and act at a level that's appropriate for the driver. So hey, let's say you've got a navigator who's more senior than the driver, maybe someone who's been working with the language for a long time. You've got a driver that's not so explicit, or no, sorry, not so experienced in it. So the navigator, may end up sort of saying, oh, "Here's how you spell that keyword," or "Oh, hey, I want you to declare a field name this. Do you know how to do that?" Or "Hey, can I help you do that?" Um, and this is really good at knowledge transfer. This is really good for helping people learn, bringing people up to speed. Similarly, if you've got a navigator who isn't experienced and a driver who is, the navigator will speak at a high level. And in this type of pairing, or this pattern of pairing, it's really incumbent on that more experienced person to not just like do all the work themselves, but really enable the navigator to ask the questions that um, uh, are relevant, or to figure out, hey, how do I explain like what I think the solution to be is to someone who is more experienced than I am. For me, this quote from pairing that says, "Hey, listen, for an idea to go from the navigator's head into the computer, it must go through the hands of the driver." Right? And that's kind of the whole idea here, is that by like literally separating out the strategic design and the strategic implementation from the person who's hands are on the keyboard, it forces the navigator to articulate in human words, what ought to happen. And what that does is it engenders learning and it engenders agreement on what needs to be done. And that's very powerful, because now all of a sudden you've got two people that understand the problem and the solution instead of just one. Anyway, I'm lecturing now. This strong style pairing is like that. And tonight we'll see that, because lucky volunteers will be pairing with me, and I think it's fair to say that in many respects there will be a knowledge mismatch. That's okay. It's a perfectly valid thing to do. Now, the other style of pairing that I want to call out is something called ping pong pairing, which is which plays really nicely with test-driven development. So the idea here is that the pairs will go back and forth as follows. So the current driver will navigator and driver pair will write a test. So the first thing you do is write the test, and then you switch up to have the other person make it pass, and then the other person writes the next test, and then they switch back again. And of course, it bounces back at ping pongs back and forth between the two people, and writing a test to make it pass, writing a test to make it pass. And then of course, also you can figure out where refactoring plays into all of this. I mean, this works really well when people are about the same level. And so then, I encourage you to apply this on Wednesday, when the person that you're pairing with is probably someone with whom you don't have a big knowledge gap with, a big experience gap with. So anyway, there's some things to be considering tonight, and then also for Wednesday. I encourage you to, if you want to learn more about this, here are some great references from Martin Fowler and Lone Falco, all about what people have learned about pair programming. Now, in this class, because we do both in-person pairing and remote pairing, or you have the opportunity to do remote pairing, we find ourselves using GitHub to share our code a lot. Now, I mean, you go back to the original literature on pairing. It was at a time where everybody just worked together in the same space. We just didn't have the tools to enable remote pairing. And literally, it was two people sitting next to each other and passing the keyboard back and forth, looking at the same screens. And that's really cool. That's great to experience. But there are a lot of other options available to us now. So, because again, the important thing about pairing is the conversation that takes place. And we can all agree there's there are pros and cons of people being in the same room versus being remote, but we want to have as high bandwidth communication. And so, especially when you're remote, it can be really effective to leverage GitHub or your version control system to move code from one person's machine to another person's machine. And that's what we'll be doing tonight. We'll be, and it's what we have the kata repository, is that we'll use that to share our code. So, the way it works is that when you become the driver, the first thing that you do is you pull down the latest changes to get the code that you just wrote while you were a navigator. And, then you integrate them in, make sure that everything still builds, and then you start the next round. And of course, when you're remote, you can share your screen and things like that to see what's happening in real time, to collaborate like that. But then at the end of the round, you push you commit your code, you push it up to GitHub, and the cycle starts all over again. There's also, I do want to call it, the IntelliJ has this feature called Code With Me that allows people to collaboratively edit the source code. It's kind of neat. It's like editing a Google Doc collaboratively. But I have to say that students have had mixed experiences with it over the years. Because because it makes it really easy to have there be a free for all, especially for mob programming, where you have multiple people trying to edit the code at the same time. So while it's something that's available to you, I don't know if it's necessarily where you want to start with pairing. It's probably easier just to look at the other person's screen, either over their shoulder, or if you both want to get on a Zoom so you can be able to see it. Again, the important thing is that you're able to have a conversation, a dialogue about the work that you're doing, so that you can both be in agreement on what you're doing and what needs to be done going forward. Okay. So, as I said at the beginning of class, we're going to be working on code katas. And the katas are these little programming problems that have, they're pretty straightforward. Nothing's too tricky about them. But there's a problem that you need to solve. There's a specification that you need to implement, you need to fulfill. But the real goal of these katas is not to solve the problem, but to learn about a particular technique for solving a problem, like a new programming language or a new framework, something like test-driven development or pairing and refactoring. And so then I guess I would encourage you that as you do these katas, even if you know what the implementation needs to be, you're not there to get it, to implement it. You're there to collaborate with other people. You're there to experience test-driven development. Those kinds of things. There's a lot of discipline in what we do in this aspect of the course, where it really is, hey, listen, I'm exploring this new programming technique, so I really force myself to follow the rules to see, how the rules work for me. I do encourage you to, or rather, I discourage you from abandoning a rule or a practice before you really had a chance to experience it and gather enough data to then make the call on how it works for you. Okay. Before I start diving into actually what we'll be doing tonight, has this introduction to pairing raised any questions in your mind? Is there anything confusing or that you're curious about in terms of what we'll be exploring tonight and tomorrow? Okay. So, well, the first time I did pairing, I kind of threw people into it, and it was kind of jarring. And so then, actually, before we dive into this, though, I think it's time to play the cheesy video. So before we talk about exactly what we're going to do tonight, there's one other resource about pairing that I do want to share with you. And so let me just share my screen in a way that's optimized for video so that it comes across better. Let's see here. Share sound, optimize for video sharing. Here we go. Oops. audio.
Hello and welcome to Fun with Pair Programming, an introduction to pair programming for students. If you're a student who is new to pair programming, you've come to the right place. This video will help provide valuable information to make you the best pair programmer you can possibly be in your classes and beyond. Pair programming refers to the practice whereby two programmers work side by side on one computer, collaborating on the same design, algorithm, code, or test. The pair is made up of a driver, who actively types at the computer or records a design, and a navigator, who watches the work of the driver and identifies problems, asks clarifying questions, and makes suggestions. Switch roles from time to time to share the work evenly and get the most out of your pair programming experience. You'll hear effective pairs constantly chatting as they jointly decide how to tackle the task at hand.
Well, actually, I don't even know where it's saving this stuff. So we create a new patient and it adds record. Oh,
right.
Probably in save data file. Mm-hmm. So it's going through, looks like a list of records.
Mm-hmm. So we probably, since we just added the height and weight, I don't know if that's actually getting written.
Yeah, probably not.
Okay.
So
why do so many thousands of students around the world prefer pair programming? Why don't we ask some to compare old-fashioned solo programming to this new and innovative system?
Wait, what was the order?
You would program by yourself, so you'd usually be just by yourself in a computer, maybe in a cube or at a single desk, and it's a very lonely type thing. It can be.
Well, it could be really frustrating. You'd sit there banging your head against a desk and trying to find, the missing bracket, or couldn't figure out why the logic in your program didn't quite work right. And with two people there, it's a lot easier to work those problems out a lot more quickly, so you're not frustrated all the time.
This is nothing new either. Most science labs take advantage of lab partners and small groups. Computer science is no different. You can learn a lot from working with other people. Students find it helps them get better scores on programming projects. Pair programming helps them learn, so they get better grades on exams as well. Mostly, students report that they enjoy getting to know the people in their classes better. This makes it much easier to interact when problems do arise, because you've got a class full of friends instead of strangers. Last, but certainly not least, students are much more likely to figure out solutions if they've got someone to brainstorm with, and this can lead to faster completion times and a better understanding of the subject matter. Students often find the whole experience much more enjoyable and less frustrating. Pair programming will also help you prepare for your career in computer science. In the professional world, people collaborate and pair program all the time, and as an expert, you'll already be ahead of the game. Have you ever spent most of your class time with your hand in the air, getting nowhere on a project while you wait for help from your professor or lab instructor? With pair programming, those days are history, and you'll find yourself having a lot more fun. Who knows? Maybe you'll even look forward to the alarm going off in the morning so you can get to class. Now that you know the basics, let's look at some simple do's and don'ts of pair programming. First, be sure to talk. Not a minute should go by when you're not communicating somehow. Don't say anything that might insult your partner. Even if you're only joking, he or she might take it personally. Don't forget to listen too. Both the driver and the navigator should be fully engaged in the project. So much so that the driver can pass the keyboard to the navigator at any time, and he or she will be ready for the switch with no questions asked.
Periodically switch positions so you can gain experience in both roles.
Switching helps prevent errors and stimulates conversation too. Be patient. Be prepared to explain yourself to your partner, and don't get frustrated if they don't understand it first. By explaining your work to your partner, you'll be helping yourself learn as well. Remember the ancient Chinese proverb, "To teach is to learn." And be sure to give the driver a little time to correct his or her own mistakes. After all, no one likes a backseat driver. Respect your partner. The golden rule is key here. Just remember to treat your partner with the same level of respect that you expect from him or her. It doesn't matter if they are from another culture, an introvert, an extrovert, a procrastinator, or the valedictorian. We are all here to accomplish one thing, and everyone has something to offer. Take breaks. You can get more done in 1 hour pair programming than in several hours by yourself. But this can take a toll on your brain. Don't forget to take a break every so often to keep yourself fresh and energetic. When you return, you'll likely see something you overlooked before. Be prepared. Be sure to do any preliminary work ahead of time and don't be late for appointments with your partner. Their time is valuable, as is yours. Hygiene. Think about it. How would you feel if the person you were going to spend a couple of hours with smelled terrible? Take a shower, brush your teeth, bring some mints. You know the drill. Have fun! Working with someone else can be a lot more fun than working by yourself. You can share a laugh, relieve some tension, and have someone to celebrate with when you get that last test case to pass. Believe me, that's a great feeling. Now that we've gone through all the things you should do as a pair programmer, let's go through some of the things you should avoid when working with your partner. Don't be a keyboard hog, or think that just because your partner is a novice and you're more experienced, that they won't bring something to the table. Don't constantly tell other people what to do either. You don't want to be the only person in the class that no one wants to work with because you're too bossy. There is another side to that coin, so don't be intimidated. Some people are afraid that they don't know enough, but chances are your partner feels the same way, and you both know way more than you give yourself credit for. Trust me, it will all be fine. The primary goal of pairing is to work together towards the best possible solution, so don't be afraid to speak up if you disagree with your partner from time to time. Your partner may as well be working alone if you're not willing to speak up. If you're unhappy with your pair programming situation, for any reason, don't hesitate to talk to your professor or teaching aide. That's their job, and they will be happy to help you resolve whatever problem you may have. As you can see, there are many benefits to pair programming, but there are also a few speed bumps. Sometimes you'll find it difficult to find time in your schedules to meet, for example. But students all over the world agree that the benefits outweigh any drawbacks that they can find.
If there's two of you working on it, typically you're spending a lot less time working on it, so this is great for homework. Then also I would say that in general, your solution is going to be better.
So if you're working with somebody and their grade or their deadline matters to you, you're more likely to get your work done at an earlier time. Also with pair programming, you can typically have higher grades on assignments. There's higher quality code as well.
This concludes our journey through the exciting world of pair programming, but there's still much to learn. Take these tips with you into your next pair programming lab and join the growing number of pair programmers across the country, the world, and beyond.
Super cheesy, but got the point across. So what are some of your takeaways from that video? It's like, what are some of the things that maybe left you curious, or some of the things you want to keep in mind, or hopes, dreams, fears about pairing?
There's a lot of different ways that you can is helpful.
Okay, yeah, right. Just having, hey, this is just collaboration. Fundamentally, yeah, there's nothing like too unusual about it. Have you all had any experiences like that, like coding with other people before? Yeah.
Yeah, so
Okay.
pair programming is
Oh, really? So in your undergrad, they had you do pairing. Nice.
first, yeah.
Oh, wow. And what were your experiences like? Let me ask.
I mean, I found one person who I really worked well with.
Gotcha. Yeah, yeah.
I know that sometimes students too. But I've seen instances where it ends up with one person who is always in the computer.
Someone a little too dominant, perhaps. Yeah, yeah.
Yeah. So there's risks to that. So like finding that out.
It's good. Yeah. So it felt it was like equal, and both people could contribute.
Yeah.
Yeah, effectively. Excellent. Cool. Let's see here. Something here. Does it have to be in class when we work together or outside of class? Oh, okay. I think I understand that question. And actually, yeah, that's something that I probably reinforce here later. But yeah, just to be crystal clear. So you can work with people on code in any of the katas. So for the pairing and the mobbing, for the refactoring kata that we'll do, basically anything that gets committed to a public GitHub repository, like a GitHub repository, yep, work with other people. Your projects, on the other hand, are your own work. So for projects 1 and 2, that is your own work. Please do not pair or mob with people on those. If you have any questions, please reach out to me. But yeah, just to be clear, if you're writing like appointment book code or koans code, that's on your own. Yeah, it's assessed as on your own. The work for the on the katas though that we do together in class, all out in the open with other people, and so that's something you can collaborate with. Did I answer the question that came into chat, Hassan?
I was just confused on specifically on the like, do we have to the final project is a pair programming one or
It is.
no? Because I got late in class, so I was figuring out what the pair programming is about.
Yeah, yeah. So again, so when you say final project, that'll be like project 6, your Android project. That's your own work. The pairing is done here in class, during class, and the goal is to spend class time learning about pairing. It's not to complete it. As a matter of fact, next time we'll talk about the let's see here. Yeah, we'll talk about the expectations. If you want to read ahead, there's this handout here that talks all about how we do pairing and how you're evaluated on pairing or how you're assessed on your pairing. But we'll cover all that in detail next time because it'll be much more relevant than it is tonight. But yeah, just to be crystal clear, if you're writing appointment book code, that's on your own. If you're doing a kata, that will be shared work. That make sense? Got all that?
Thumbs up.
Cool. Awesome. Thanks. Oh yeah, maybe you got the video on. Nice. Okay. Okay. Let's see here. I think, well, before we really dive into all this, I do want to I want to check in on how we're doing with with everybody's ability to contribute to the katas project. Is there anybody who has not been able to push to the katas repository? See how we're doing on people's ability. Okay, yeah, good. Lots of people have been able to push. Excellent. Okay. Let's see here. Awesome. Okay, so then. Okay, so tonight I'd like to be able to demonstrate pair programming. In order to do that, I'm going to need some partners. So then, what I'd like to be able to do is what I call an operating theater exercise. So you think about like how doctors and surgeons learn how to operate. One of the things that they do is they see an operation in progress, right? You know, you see the doctor shows where there's like a bunch of people sitting above the operating room, you know, looking in. It's kind of like that. So, you know, folks here in the classroom, I encourage you to volunteer. I'm not going to force anybody to volunteer, but I'd like some help. Pair programming on a simple code kata called the Fizz Buzz kata. And we'll have an opportunity to pair together. We'll do some, you know, strong pairing, some strong style pairing, maybe some ping ponging. We'll see how it goes. Now, I do want to call out that we're still very early in the course, and that other than the koans, you probably don't have a lot of experience with pairing, or with writing Java, and that's okay. It's all part of what we'll learn. And I also acknowledge that anybody comes up here, yeah, you're going to be in front of the class, you're going to be in front of your peers. You know, it's understandably a little intimidating, but I do encourage you know, folks to try out pairing. I hope you be prepared for Wednesday, and it'll help, you know, the class see what it's like to pair also. So I'll thank you in advance for having the courage to put your name in there. So. If you would like to pair with me, and actually either here in the classroom or if you want to do it remotely, we can certainly do that too. I'd like you to do the following. So here in the katas repository, if you look in the Fizz Buzz directory, there is a pom.xml file. And here, and I'll make it a little bigger so folks can see, there is a section of the pom.xml file called developers. And I would appreciate it if some people would volunteer to pair with me tonight by replacing, by putting your name in the name section and choose which role you want to be. If you want to be the navigator, if you want to be the driver, I'll be the other role. And just do that by, you know, deleting whichever line you don't want to do. And I'm hoping that we can get, I don't know, 4 or 5, 6 people who want to volunteer to pair with me on the following problem. So there is a kata called Fizz Buzz. Actually, has anybody heard of Fizz Buzz? Yeah, I'm seeing some people nod. Okay, we can do that. Right. The whole idea, I mean, it's a super simple kata. And you know, and actually here's what these katas look like. It's got a little it's got a little like problem description, which is like a narrative. So maybe it's like some of the assignments that you got in your early CS classes. And the whole idea is the following. It's like this children's game where you know, it's played in a classroom, and the teacher will, you know, say a number starting at 1 and just, you know, going up there. And the teacher will say the number, and then the students are supposed to respond with the following. They're supposed to say the number back unless it's divisible by 3. If the number is divisible by 3, they say fizz. If the number is divisible by 5, they say buzz. And if the number is divisible by both 3 and 5, the students are supposed to say fizz buzz. That's a fun game, I guess. And so anyway, so back and forth. And so the whole idea is that we, you know, write a program that will ultimately print out something like the following. It'll print all the numbers, and if the number is divisible by 3, it'll say fizz. So here, you know, number is 3, number 5 is buzz, number 6 is fizz because it's divisible by 3, et cetera, et cetera. When you get down to 15, you say fizz buzz. So the whole idea here is that we have very, very simple logic. And, you know, as I was saying before, the goal is not, oh, let's implement this, because, yeah, it's really easy to implement. But instead, I want to use this very simple exercise to explore pair programming, to see what it's like, to show off what it's like to have this conversation between 2 individuals. And to do so in a way where we're not so much focused on the problem as we are focusing on learning test-driven development, on learning how to collaborate in pair programming. I don't know if we'll get to the stage 2. We'll see how much time we have left tonight. But anything people would like to discuss with regards to Fizz Buzz and what the kata for tonight will be? Okay. So that's the kata. That's the problem that we're looking to solve. And what we'll do is we'll follow a red-green refactor. cycle, and we'll have a little unit test. Well, we'll build up unit tests for our Fizz Buzz class. And then, well, we can also use the integration test too if we want. And then we'll implement the production code to make it fast, and make it pass. And then if there are opportunities to refactor, we will. So we'll do some red-green refactor for that. And be clear, though, once again, we're here to explore the problem. We're here to explore pairing and TDD and things like that. It's not just like get it done and go home. In this case, we're there to savor the experience, if you will. And so what we'll do is we'll have a round of 7-minute, what are called Pomodoros. So this is a common learning exploration technique that sets these like 7-minute time boxes that people work in. And what this does is it helps provide focus and also provides just a rhythm to the work that has a built-in time for reflection. So we'll go through the volunteers who will pair with me for 5 minutes. So you're going to be up for 7 minutes, 5 minutes of pairing, of active pairing, and implementing the code, followed by a 2-minute reflection on what we experienced. And this is for learning, right? It's to engender improvement and to figure out, hey, what things were effective, what things weren't. And then we'll move on to the next volunteer. We'll use GitHub to share our code, and we'll go through a couple of these rounds until either we run out of time tonight or we get through the kata. And after every couple of students goes through, we'll open it up for discussion in terms of what people are seeing. Right? It's important that the audience observe too and is able to provide their feedback, share their observations about what they see. That's what we'll be learning about tonight. So any thoughts on that? People like to share? Any confusions, questions, wonderings that people would like to discuss? Okay. Well, so again, I encourage people to sign up here in the pom.xml file for the Fizz Buzz directory. Has anybody done it yet? Thank you, Sam. Okay, we're looking for some more volunteers here. Oh yeah, Liana. Oh, excellent. We got a couple of people. This will be great. But in the meantime, hey, let's take a break. Let's take 10 minutes. We'll come back at 7:02 and kick off our pairing. See what it's like. And we're back. So, first part of class, you heard me talking a lot about pair programming, and so we talked about we talked about what pairing is, also how we're going to collaborate to pair mod programming using the kata repository. So thank you to everybody who was able to took a moment to validate that they can push that repository. It'll save you some time and frustration on Wednesday when everybody's going to be contributing to it. And after a discussion about what pairing is all about, highlighting the 2 roles, driver and navigator, talking about some different styles, watching a cheesy video, it's time to start in on this Fizz Buzz kata that we have. And so what we're going to do is we're going to have brave volunteers from the audience, either here in the classroom or people who are remote, to pair with me for a couple of minutes. So 5 minutes on the keyboard, followed by 2 minutes of reflection, to develop this very simple Fizz Buzz kata. And so then I asked for people to volunteer by adding their name to this. Adding their name to the pom.xml file in the Fizz Buzz directory in the checkout. And we've had a couple of people sign up, so we'll start there and we'll see how it goes. So cool. So Sam, thanks for volunteering. Do you mind coming up here and standing next to me? Now you said you want to be the driver, so your hands are on the keyboard. That'll be great.
Yeah.
Okay. Yeah, and actually, would you join the Zoom so what we can do is share your screen so we can see you typing, and then we'll put that up on the screen so people at home. I need to make sure that everybody can share. Advanced sharing options. All participants can share. Yeah, I'll be on the homepage of Canvas. Also, yeah, it's also on the calendar invitation, I think. Yeah. Yeah, there you are. Oh yeah, and turn off your audio, please. Yeah, let's use my microphone and speaker, otherwise we'll have feedback. Cool. Okay, thanks. Yeah. So yeah, how about you share your IntelliJ on the entire? Oh, so you already are. Awesome. So I'll just put that up so everybody can. Oops, see that?
Yeah.
No, it says I'm still sharing.
You're still sharing. Yeah.
So yeah. Yep.
Okay. Oh, you're displayed up there.
Yep, just
Okay.
replace the current share.
Yeah.
Nice. There we go. Excellent. Let's see. Oh, I gotta go off here. Great. Hopefully that's viewable for everybody here in the classroom at home. That all looks good.
Yeah.
Okay. Actually, can you make it just a little bigger? So I think like Command scroll up or something will make the.
I don't have a command
Oh,
button
sorry.
or
Oh,
a
yeah,
scroll bar.
Sorry.
So,
Yeah. Okay.
all
So
right, yeah,
maybe
here we go.
Control. Oh, you remember.
Settings.
Nice. Okay.
All right. Editor. Font.
Oh, there you go. Yeah.
16, I think would be good.
Yeah, that looks pretty good. Okay. Yeah, that's good. Awesome.
Shout out
Okay, cool.
if it's not big enough.
Actually, okay, so I'm going to start the. Actually, before I start the clock, let's take a minute to strategize here
Yep.
a little bit. So, okay, we got Fizz Buzz.
Yeah. Can I grab
Oh, nice. Yeah, good call. Good call. Yeah. So, maybe I'll ask you first. I mean, have any thoughts about sort of like what would the coach look like? Maybe what tests we should write? You know, first, how that looks like.
I mean, the ultimate functionality that we're going for is divisible by 3, divisible by 5,
Right.
divisible by both.
Yep.
Right. So I figure iterating through each of those. I mean, we could even break it down further to can it print anything? Just printing the numbers, you know, 1 through however far our program is going, 1 through 15 or 30 or whatever.
Right.
Yeah. So simple, just iteration.
Okay, you're right. Yeah.
Or something.
Okay.
Yeah.
Excellent.
So I think those would be kind of the
Yeah.
breaking it down into those steps. Yeah.
I like that. Yeah. So we'll have sort of a simple building block, and then we'll just have the iteration on top of that. Okay.
Yeah.
That sounds good. Yeah. Let's start the timer here. So we'll code for 5 minutes and see how it goes. Let's see.
Okay. Yeah.
Okay. So I like to do this test driven. So if you could open up the Fizz Buzz test. Ah, great. Okay. And so how about you just delete that Canvas Stage 8 kata class test? Yeah. That's probably not so interesting. Yeah.
Or use something.
Oh, absolutely. Yeah, feel free to reuse it. Yeah. So let's see here. I think the first test. I don't know. What would you like the first test to be like? What's the most simplest thing that we could test?
The most simplest.
Yeah.
Print a number.
Okay. Well, and what number? what number to print?
If this is like a children's game, we'd start counting at 1,
Okay.
not at 0. Right?
Okay. Yeah, I like it.
Yeah.
Right. And so okay. So
about the
let's
user.
have a test
Yeah.
that validates that when we ask for the Fizz Buzz value of 1, we get 1. So.
First is Fizz Buzz.
Cool. Oh, it looks like things aren't compiling there on line 9. I think, look where, okay, yeah, nice, okay. Yeah, so here, so if we want to, I think we want to, assert that when we ask for the Fizz Buzz value of 1, we get the string 1 back. Yeah. Okay.
So, mind if I look at the Fizz Buzz? It's
Not at all.
Well, there's
nothing
nothing
there right now,
Great.
right? Yeah,
Okay.
and so we'll need to add something. So then, what are you thinking right now?
A method.
Oh, I like that. Yeah.
Yeah, right.
Okay.
So a
Yeah.
method that would be
Just
like
call it Fizz Buzz.
Yeah.
Right. Yeah.
Or
Okay.
Fizz Buzz value 1.
Okay.
Yeah.
Yeah. Great, and so you can create that method. Do you know how to use IntelliJ to create that method? Okay, so then, yeah, you can either do, let's see here, I think it's Alt-Enter on Windows. That's how I like to do it. That gives a little context menu for saying that. So yeah, create the method. Cool.
Do you want it public?
I think it's fine to be public. Yeah. Now, okay, yeah, so then, cool. Now, okay, do we want to print it or do we want to return it? Because, like, if we just print it to standard out, remember we saw last week with those integration tests and everything like that, it's a little bit more difficult. So maybe this one, so maybe instead of printing it, we just have it return the value. So, oh wait, so you can, I recommend that you use the rename refactoring, so that way the call to that method will also be renamed. Yeah. Yeah, so let's call it get or.
I was thinking output, or you want get?
I think it is get because we'll have it return the string. So yeah, so if you hit enter to have it take that value.
Enter.
Yep, and then yep, and see, I renamed it there. Nice. Okay, and let's have it return the string. That is yeah.
So.
Well, okay, I'm sorry. How about you change the signature of the method to return the string? Yeah, that's what I meant. Yep. And now this is going to compile. Let's have it return null for right now. Because, hey, I'm being super disciplined. No, just have it return null. I'm being super disciplined. Let's have a test that fails first. Let's watch it pass.
Oh, yes, red.
Right, okay. So that's the integrate. Oh, yeah, they got color. Oh, nice. I like that. I like that. Not nearly as dark as the heck. Call.
So do we want to have this output or just from it?
Well, oh, no, I think we want to take the value and assign it to a variable, then we can have an assert statement, right? Because we're writing a unit test, and we should always have the assertion of the expectation. Yeah. So
verbal equals.
Yeah, there you go.
That assert equals.
I recommend you use assert that, the Hamcrest APIs. That's what I like. Yeah, assert that, and then you can do an alt enter. Yeah, okay, cool. Yep.
And so this is going to be like assert equals.
Well, yeah, you need to say equal to. So no, sorry, the string. Okay. So let's import the assert method there. Yep, like that. Yep. And then you want to say assert a test. So then just send it the test, and then you have the method equal to. Yep, and then say what was equal to the string 1. Oh yeah, nice. Yes, import that. Yep, is that first one? Yep, from Hamcrest. And then equal to string 1. Nice. And let's add enough parentheses to make everybody happy, and then that. Nice. Okay, so let's run this test. Remember how to run the test? Yeah, right there in the margin.
Keyboard shortcuts.
Yep, let's see if everything compiles.
Terrifying.
Doing great.
That failed as expected.
Nice, failed as expected, and that's for 5 minutes.
All right.
So, cool. How about you commit the code?
Yeah, sure.
Okay. Very nice.
So,
excellent. I think you just do get.
Just get everything.
Go ahead and do get
well,
add.
Here, let me just in case it doesn't shout at me. Can I just do a poll?
Oh, good call. Yeah, because there might have been changes from upstream. Yeah, I'll merge those in.
No.
Okay, they were. Yep.
So the readme actually somehow.
Oh yeah, I changed that.
Okay.
Yeah.
Now I can just do a get add, just everything that changed. Nothing. No.
You need a dot probably.
Get commit -m Commodore added first test. Git push.
Awesome. Okay, let's take 2 minutes and reflect on what you learned. So, deep breath. What was it like?
Huh?
What was it like?
It's interesting, just having both like performance anxiety and no shame.
Yeah, I know. Right?
Presenting to a crowd. Yeah, I mean, it's this is my first time doing like test-driven development, so there's some of just the learning there, and also just keeping it very, very simple.
Yes,
so, yeah,
right. Yeah.
That's a key thing. So, yeah.
Cool. Okay. I was gonna ask you. Okay, so let's see here. That was like for you. I'll say about my feedback.
Please, yeah.
Well, first of all, I really appreciate you getting up here, being the first person, so setting the example here. And also, I liked like how we went back and forth. I appreciate you sort of being open to things. Looks like you're already pretty comfortable with the IDE. That's good, and that helps. And I realized I probably wasn't as like clear in my intention or expectation in terms of like, oh, let's just have a simple method that you test. I think you very reasonably said, oh, let's just print it out. And but again, when you print something to standard out, it's hard to unit test it, or you just need to use an integration test for that.
Right.
So I think we can start out with the approach of, hey, let's just have the little method that computes it. We'll have the logic, and then we'll go from there.
Yeah, no, that helped me. I mean, this helps me because I haven't started my homework one yet either. So this helps me kind of think about how to start that.
Yeah, so, and I recommend that. Yeah, you take this approach of like, oh yeah, just like what's the simplest little logic that we need to have, and that way, you'll get it all validated. And you'll have the suite of tests to tell you when something is wrong, and you'll get the code coverage. So I think that's why I like to emphasize this approach.
Yeah, to approach with this, test-driven stuff. So.
Excellent. Okay, cool.
Yeah.
Awesome.
All set.
Thanks. Appreciate it.
Yeah.
Golf clap, everybody. Yep. Okay. Yes, there you go. Take a bow. Awesome.
Oh, all right.
Okay. Yeah, now we'll play the get off the stage music. That kind of stuff there.
Yeah.
Cool. Thank you, Sam. Okay. I'm going to pull down, oops, I'm going to share again so people can see what I'm doing. Okay, let's see who's up next. Let's see here. Oops. I keep doing that. Did anybody sign up in student 2 position? No? I'd like a couple more people. Awesome. Yeah, Eliana? Are you Eliana? Awesome. Am I saying your name correctly? Okay, good. Awesome. Thanks. Yeah, come on down. Excellent. So please join the Zoom if you haven't, so you can share your, because you did say you wanted to be driver also. Yep.
Oh, we can do either, so if you want to switch.
Oh no, what's your preference?
For your...
Okay, let's see what it's like with me being the driver. Yeah, okay, we'll do that then. So then, let's see here, you can see the screen, okay? Okay, excellent then. So, okay, where to start? We have this test.
That's a good one. So
oh, yeah, right. Actually, I want to see it fail too. Totally. Okay. How do you want to make a pass?
Let's see, it's in the Fizz Buzz class right now.
Fizz Buzz, small text. Yeah, so it's got this main, and it's got get Fizz Buzz that returns null, and that's why it's failing. Okay. What do you suggest?
So with the test-driven development for this class, were we saying that we wanted the hard code for the test that we were currently doing? Or?
I like that. That's a good approach, right? Because yeah, again, it's like red, green, refactor. Like see it green, even if it's super simple. So that would just be what, hard coding to 1. Is that what you had in mind? Excellent. Okay, cool. Yeah, and so then, oops, we'll run this again. It ought to. Yes. Cool. Okay. So what's the next test that you want to write?
So we're also going to be going with just good input first. We're going to do test validation for the bad inputs later.
We can do whatever, but
probably good ones though.
Okay. First. Sure. Okay. Cool. What's the next good one? Oh, stop that. I'll see if I can turn off the AI here in a minute. So it's really distracting. So yeah. So like, what's? So
the next one would probably be what would be the next expected input, which would probably be 1, 2.
Okay. So 2. Okay. So yeah, print. Gee whiz. Do you mind taking the AI assistant? Okay. Yeah. But actually, is this the right test though? Let's make sure. I think it is. Right. We're saying Fizz Buzz value of 2 ought to be the string 2.
That's not right, is it?
Oh no.
I didn't read all
That's right,
tests. Is it supposed to do 1 and 2, or is it supposed to do 2?
Oh, good question. Yeah, so I mean, I think the intent, at least my intent for this method, is that it just returns, it takes a single number, so it's not through 2, it's just for the number 2. I don't know, that's a really good observation. Yeah, okay, so yeah, it's sort of a single value and a single answer, so yeah. So I think let's see, okay, so let's run it. Awesome, it's gonna fail. Okay, so how do you make it pass? Any ideas?
So now we would want to make both of the tests pass.
Yeah.
So now would be the case where we take in the input and actually change it into a string.
Yeah. And you know off the top of your head how to do that? Stop it.
So not as versed in Java, can we just recast an int into a string and that works?
Give it a try. Just like string of I. And not so happy there. Snap. Okay, it says you cannot cast it. So actually, I know this one. So you can, well, you got a couple of options. You can say like, plus you can concatenate it with an empty string, right? That'll work. I kind of like using the string.value of method. So, yeah, let's give that a try. Oops. Nice, that passed. Let's run them all. Let's run everybody in the class. Nice, cool. So we went from red to green. See any opportunities to refactor? Either this test code or...
I think I'm supposed to ask you that.
Oh, sorry.
Do you see any cases for refactoring?
Yes, I do. Keep going. You know, the class variable I think we can come up with a better name there.
More descriptive?
Yeah. But what? Let's see here. Let's oops. So let's code. Where's it? So factor name. I don't know. Value. Number even. I think it's, I don't know. Number maybe. Yeah.
As long as it's not a keyword in Java.
Right. Yeah. Cool. Okay. Yeah, everything's passing. So, okay, what's next?
Is there any refactoring for the test?
I don't see any. Well, I mean, I suppose we could actually, I kind of do have some duplicate code here. So, yeah, maybe do that. So let's see here. Yeah, I'll refactor this into a variable. I'll introduce a variable for this. I'll call it number. I like that. I'm going to move it up here, and then yeah, just take all of this, and I'll turn it into a method called get Fizz Buzz. Oops, Fizz Buzz value. And it says, do I want to replace it? I do want to replace that. Nice. And now I can inline this factor inline variable. Yeah, there we go. Actually, I probably don't even need that test variable either. I'm going to use the keyboard shortcut to inline that. Yeah, that's pretty good. Just complaining about something. Inline variable. And inline this variable too. Nice. And then I'll run all my tests again to see if they still pass. Sweet, it's in the time box. While I'm committing this, what do you think? What was it like to be the navigator?
Pretty interesting, considering that you know more about
I know, right? Yeah, it makes it very interesting, but
yeah, usually when I've done pair programming before, the navigator is always the one that knows more and they're teaching someone else, so it's interesting.
Yeah, well, yeah. Thanks for mixing it up in that respect. What questions are you looking for? What are you so curious about? Either in terms of pairing or like maybe with section of kata? What's on your mind?
I mean, the next question was going to be if we needed to test the class itself and not just the variable, because the first time we did test in development, we were testing if the class actually instantiated correctly first. Yeah,
right. Well, and it's kind of, yeah, interesting. Like if you look at sort of the class that we're left with here, you know, this is just like a function.
And that's all it is.
Yeah. Maybe another opportunity to refactor. So maybe we missed that. Where you have, you know, this class that doesn't have any state. There's no instance. You know, there's no instance variables or anything. So yeah, maybe a future refactoring is to turn this into a static method and go from there. That's an idea. Cool.
Anything else?
No, that was going to be my question. Excellent.
Efficient.
Yeah, it's right on. Awesome. Thank you very much for that. Awesome. Cool. Super sweet. Okay, we got any more? Now we've seen a couple people do it. Anybody else sign up? Anybody who's remote? Want to try this remotely? See what it's like? You have to be on camera. You have to come off microphone though. We got a lot of people who are remote. It does, yeah. I don't know. And so then we could do a longer time box, I suppose. Yeah. Michael, you want to talk? Okay, awesome. Yeah. Yeah, sure. Let me go back here. Yeah, so you're.
So get Fizz Buzz value. Oh wait, no, that's. Oh, I'm in the test, so.
Okay. Excellent. Okay, so here we go. We'll do 5 minutes, and you're navigating.
Yeah.
Okay.
So what would you want to implement next?
I think it's time for 3.
3. You want to put 3?
I think it's time for 3. So then, yeah, actually, now that we've simplified these, it's pretty easy. So I'm going to duplicate the code,
and then you can replace the equal to with this, the string 3 as well as the get Fizz Buzz value.
That's after I learned how to spell the word third. So yeah, it's really 3, and then this is going to be Fizz, right?
Oh yeah.
Right, because it's divisible by 3.
Okay.
Yeah. Okay, so
sorry.
then we're gonna run this. Watch it fail. Yep, expected Fizz, but was 3, and so okay, what do we need to do?
So since that number is divisible by 3, right? Let's define what's divisible, right?
Right. Okay.
It's going to become a whole number when you divide a number by another number, right? You receive a whole number, right? So what we want to do for our get Fizz Buzz value is we want to make sure once you divide the number by 3 or by 5, it's going to return a whole number, right? And so the next step here, I think, would be, how would you want to start this? Do you want to hold it into a variable, like the output?
We've got it. We've got the input variable.
We have the input variable.
Yeah.
Do we want to have do we want to store the output variable? Do we want to store the output in a variable, or do we want to return?
I kind of don't think so. Yeah, I mean, we could. I don't know. Here's what I was thinking. I was going to say if basically this. Stop. Okay, so say a number is divisible, so modulo 3, right? Yeah. Okay, but that's not right. Yeah. See, it's getting ahead of me, so I think I need to tell the AI to shut up and have it return Fizz. That's what I was thinking, right? And then otherwise, I don't know. I like my else. I like my nested else.
Okay, so we want to. So the whole point of me asking that question was, did we want to have it in a variable where we store the output of, number mod 3 is equivalent to 0 in a variable before, like checking it?
Oh.
That's. I mean, it's just a preference.
Let's give it a try. Let's see what it looks like. So yeah, that was my thinking here. But and so it'd be like this value we'd want to store in a variable.
Yes.
Okay. So yeah, so let's introduce a variable for that. And factor variable, and we can call it what is divisible.
Is divisible
by 3. Well, actually, it's not. It's not really is so much as it is modulo 3. Yeah. Okay, so let's rename that. So factor rename, and then let's see here. Yeah, modulo 3. Yeah, I don't know.
It's just a preference.
Yeah, I think it's easier to read if it's inlined actually. So I'm just going to inline that. No, it's good to play with the code, isn't it?
Yeah.
Yeah, inline variable. Yes, there it is. Okay. Let's run it again. See that makes it pass. Nice. Okay, so that was the red, that was the green. Time to refactor.
Yeah.
We were talking about at the end of the last round making this like it's a function, and something we should just treat it as one. So. Yeah, so
do we want to, instead of naming this to get Fizz Buzz value, do you want to rename it into something like more resembling what we want to get out of the function? Because right now we're trying to get, whether it's divisible by 3, right? Instead of just returning the string value of number.
Well, I mean, the function itself does both. So yeah, I mean, I think in terms of the name, we need to have something that's general enough, so and descriptive enough. Because we want, you know, we want to hide the implementation, I guess.
Yeah.
We don't want to say, you know, if it's a little like that. So I think I'm okay with the name of it, but I think what I want to do is I want to turn this into like a. So I guess there's no reason to like in here when we have the get Fizz Buzz, we don't need to create an object anymore, right? I don't think we need that. So what I'm gonna do is I'm gonna turn this into a static method by just having us instead call call the method instead calling it on a Fizz Buzz instance. We're just gonna call it on the Fizz Buzz class, and it's complaining about non-static method blah cannot be referenced from a static context. So I'll just make it static.
Yeah, it's obvious that it's static.
Yeah, and it seems to compile there. Let's compile here. Well, great. Let's run the test again. Let's see how that goes. Cool. That was a good refactoring. I think that works well. Right now, just the code is just a little bit more simple. As a matter of fact, yeah, this method itself is just getting kind of silly. Yeah. So how about we inline this method right here? So we can inline the entire method, which means replace all the calls to this method here in the class with the body of that method. We can do that. And say inline all usages, remove method, can use it 3 times. Nice. Yeah, okay. That makes it pretty simple. It's pretty easy to read that. Nice. We'll run the test one more time and see how it goes. Yeah, nice job.
Now instead you're just calling the class instead of an instance of the.
Yeah, right. You know, and I think that's this is functional, right? Because there's no state in that object. Nice.
Would it be also more efficient this way?
Oh, it would. Well, I mean, it would and it wouldn't. So, like, yeah, you're not allocating the object, but I bet the JVM is pretty smart about, saying, oh, this is a super long, short-lived object, and optimizing it away or something like that. Cool. Awesome. Okay. So then, what do you think? What was it like being the navigator?
Normally, like, my brain works while I'm typing at the same time.
Oh, yeah. So, how's this different?
Because, like, this time I'm not actually typing. I'm just, I'm, like, collaborating. Like, someone's in my head, working with me.
Yeah.
But it was a good experience. This was really nice.
Okay, good. Excellent. Yeah. Awesome. Let's see here. Yeah, and it's sort of working in these quick little things. The 5 minutes go by really fast, it seems. Boy, yeah, okay, yeah. For me anyway. Nice. Although it's actually I need to figure out how to turn off the AI because I really don't want it here. So let's see if I can ask it. Oops. Oh, I don't want the recommendation. I want that. Hey, I'm coding with some students, and I really don't want Copilot code completion for the next 30 minutes. How do I temporarily save you? Let's see what it says. I would disable the entire plugin. Really? Okay. Yeah, but I have to restart IntelliJ, like that option that doesn't require. Oh, like here or something? Yeah, let's give it a try. Okay. What is this? That's probably history, new conversation. Yeah, it doesn't require disabling. Plugin. That's why it's temporary. I have no idea if I'm AIing right. I just have a conversation with it.
Yeah.
Let's see. Temporarily disable Git Copilot without disabling the plugin. Oh, there you go. Command Shift P. Command palette. Type Copilot enable disable. Okay, there you go. I like that. Command Shift P. No. Okay.
Did you do Control or Command?
I did. I thought I did Command. Command Shift P. Am I not in the right context?
What if
Command palette. Yeah, sometimes it makes things up, doesn't it? Oh, I wonder if that's like VS Code or something. Command palette.
yeah, VS Code has.
Yeah, that's yeah. It gets confused sometimes. Okay.
Maybe it's in the settings.
Yeah, maybe. Well, actually, yeah. Can I just say Copilot? Copilot. Toggle. Have Copilot widget. What's the widget?
This one.
Open settings. Maybe. Let's go find out. Screen reader. Check for public updates. Nope. Okay, well, fine. Well, I'm almost done. Maybe I'll figure it out later. Awesome.
All right,
Thank
thank
you. Yeah, very good. Off that. Nice. Yeah. Yeah, yeah. So let's break for like, yeah. What are your observations?
For some of this like collaboration, one thing that I think is important is so like thinking about like, oh, I wrote the line of code to the same thing.
Oh, were you like, it's like, oh, that was me. I made a mistake. They refactored my code away. Yeah, I'm being erased. Yes. Yep.
All right, we'll do something else, but
yeah. Well, and it's learning, right? I mean, there are things that, like, we only just saw now that weren't obvious there. And yeah, and actually, I'm really glad you brought that up because, yeah, that's okay, right? We do it in our own code, but yeah, it's just kind of much more visible when you're in front of the entire class and you're working with someone. Exactly, right. And remember, this is like low stakes. You're learning how to pair here. But yeah, it's I think that's one of the things where you kind of have to learn to let go, and it's, I mean, I don't think of it as a mistake. It's just like, okay, something that we didn't know. And actually, there's also an argument to be said that, like, hey, we're keeping our options open by trying not to make it perfect the first time. Instead, we want to explore to find the path that works for us. Awesome. Okay. That didn't seem to work. That didn't seem to work for IntelliJ. Are you sure there is a command palette for IntelliJ? You might be thinking this. You might be thinking VS Code. You're right. You are correct, right? Yeah, it's like, okay. Tools. Right? Is it just like making stuff up? GitHub Copilot. Oh wait, there it is. Log setting log. Okay. Uncheck enable. So it's like AI, so close but yet so far, right? It's like, okay, you got it right here. Edit settings. Yeah. Okay. Okay. Well, anyway. I'll give some feedback later. Excellent. Okay. Cool. Boy, it seems like we're almost done here. Anybody else want to? Oops. Why do I keep doing the wrong keyboard trick? Let's see here. Anybody else sign up? Anybody else want to take a swing at it? Oh, anyone else want to try remotely? Let's see here. Yeah, it's okay to be shy. I understand. Here again, tonight it's all about seeing people do it. And listen, if no one, I'm not going to force anybody to do anything they don't want to do tonight. On Wednesday, you'll have to talk with other people and stuff like that, but you won't be up in front of the class. You won't be recorded or anything like that. So what is that? Oh, yeah, no, sorry. Yeah, just to be clear, like, hey, when everybody's here, you'll all be working in your pairs and stuff like that, and I'll be up here, reading or something like that. So yeah, no. Yeah, so no, the operating theater is only tonight, although we will be doing something similar with an operating theater mob in a couple of weeks. So, but there it's like, it's a whole, we'll just have the tables up here. It'll be like 7 people all talking to each other and stuff. So, yeah, it's a different dynamic than mobbing. Okay. Well, I'll just shout out, what's the next test that we should add? Sorry? Yeah, I'm pretty sure I committed and pushed things up. I don't know, is it valuable to do 4 at this point? Because we expect it to pass, right? Yeah. So okay, yeah, yeah, do 5 and buzz. Or yeah, 5 and buzz. Print 5. And then thank you. And then watch it fail, make it pass. Nice. Okay. And then I don't know, he's just going to come up with it for me. There we go. And yeah, stop that. What was he complaining about there? It's always false. Oh, that's interesting. See, okay, so it's like AI. It's like, okay, yeah, you think that's the right answer, but yeah, that's interesting. So like it comes up with that, but this isn't going to work. So actually, let's leave it in there, and we'll explore why it doesn't work once we have a test that fails. So then now if we run it again, oops, in the wrong place. It's not used to the UI. Yeah, that one's going to pass. But now, if you and actually, this is again, I encourage you all to use the yeah. To use Copilot, right? Along with that, but you got to check its work, right? Because like if I didn't have this test, now I expect this test to fail when I run it. Yeah, this test will fail because the Copilot said, oh yeah, this is what you want next, and although IntelliJ was smart enough to tell me. It's like, hey, this is always going to be false. So, oh yeah, a little suspect there. So this isn't the right thing. I mean, what's the right thing to do? Yeah, this should be like the first. Yeah, it should be like the first clause. So then we'll just let's cut and paste it. Let's put that up there, and then we'll just fix up the code. And then we need an else if here. Else. Yeah, now let's try it. Damn it! I'm not used to those icons there, and so I click on the run thing. That's okay, cool, that works. Check everybody else. Okay, so yeah, neat. Okay, everybody passes. Let's see here. Well, are there other tests that we want to write? Oh yeah, so let's do some some negative. So yeah, what should happen when we get a negative value? Actually, yeah. So what should 0 be? It should be Fizz Buzz because it's visible by both. Because it's visible. Okay. Yeah, sure. We can. That's interesting. It's their guesses there. Okay, sorry. Yeah. So we want 0, 2, 0 also. 0. Zero equal to Fizz Buzz, which we should expect there. Let's just see. I mean, we're not gonna, so this is really interesting. Like philosophically, it's like if I write a test I expect to pass, is that an interesting test? It might be, because if I was to go and change the code, I want to make sure this test still works. So it's kind of an interesting call. I don't know. And then I don't like this invalid input. I don't think that's what we should. I think we should throw an exception instead. So yeah. So I'm going to say nice. I'm going to say assert throws. Illegal argument exception. Yeah, sure. That's nice. Oops. Throws. I imported that, I guess. So now if I run this, I expect it to fail because it won't throw an illegal argument exception. Yep, nothing was thrown, so let's go throw it. And actually, is it smart enough to so if oh yeah, there it was. Oh. There we go. Nice. Didn't indent it correctly though, or did it? 1, 2, 1, 2. Oh yeah, it's not indented correctly. There we go. Nice. Okay, let's try running. Yeah, cool. Okay, excellent. Okay, well, so let's see here. We're getting some good tests going here. Oh, something's failing. Oh, interesting. Right. Yeah, yeah. Okay. So like this fails now because yeah, because the logic that I implemented was less than 1. So it should probably be less than 0. Yeah, try that. Unit tests. That was cool, right? One of our, we made one of our tests fail because of logic. This is why it's nice to have that suite of unit tests. Yep. Right.
If this was to be used ultimately for like children, they would represent.
Good point. Yeah, right. And so then I guess, yeah, no, you're right. And those are the kind of conversations that are much more likely to come up in a pair than just working on your own. And here again, it's letting the navigator be creative and sort of thinking. Again, I call it strategically, or maybe it's just thinking more broadly about what the problem is. So yeah, cool. Nice. Okay. Let's see here. Implement more kata logic or more Fizz Buzz logic. So let's see here. Since we've got a little bit of time, I think let's explore. I think when Sam was up here, we were initially talking about this is like supposed to be the output here, right? Is that it prints all this to 100. Let's do the following. Let's take a look at the command line program. So right now it just prints missing command line arguments. And that's not so interesting. So what should the command line program do? And let's write an integration test. Just get some more experience writing integration tests and stuff. So what do you think? What should the command line program do? And so what tests we want to write for the command line program? Oh, you actually want to do parrot? Yeah, you want to? Okay, yeah, come up here, Sam. Yeah. Let's give you a little bigger time box this time, too. Actually, would that be okay?
Yeah.
Okay. That'll be the flashlight. Yeah. And did you want to drive or did you want to navigate?
Sure.
Okay, yeah, so good. Sorry. Do you want to drive or do you want to navigate?
Yes.
Which will
I will drive, yes.
Okay, drive. Awesome.
All right, I need to pull first.
Yeah, pull and share your screen, all that good stuff. Nice. Okay. Start timer. Okay. There we go. Cool. Class. Yeah.
So we're looking at command line arguments, right? So
right. And so the specification says to print the numbers 1 through 100. That's a lot to test.
Sure.
Although maybe it's not. So yeah, we can have it do that. So maybe we just want to validate the first I don't know, 5, maybe 15 lines are correct.
Are you envisioning the arguments being a to and from value or start and end?
I don't even know if we need that. We just have it just print the 100. Then we probably need to validate all 100 lines. Probably need to validate the first 5, or maybe even 3, just to make sure that it's called. But yeah, it's interesting. So yeah, so let's talk about the integration tests. Yeah, so can you go to the integration test?
Yes.
Let's just do that. So yeah.
How to minimize
the what? Oh, that thing? Yeah.
There we go.
Yeah, so right now it invokes the main to get the result, and then just test what's written to standard error. So we don't want this anymore. We'll want so basically we'll get let's change it so that we get the text written to standard output instead.
This one is just going to be standard out or standard
It is standard out. Yep. Okay. Nice. Okay. And how about you? Let's see here. Then what we want to do? We'll write the Fizz Buzz value on each line. So maybe we can. Yeah. How we do the following? So instead of contain string missing command line arguments, how about we just say I always have a string that goes 1 2 Fizz 4 Buzz. So I think like that. And let's put that in a variable so that we can see it a little bit more easily. Sure. Okay, cool, nice.
So, so I can replace with variable?
Well, you can say extract variable, yeah. So if you go, yeah, right, very nice. Okay. Yeah, and let's just say, okay, sure. But this as, I don't know, like maybe just expected or, yeah. Expected out. Sure. Sweet. Yeah, and then how about you just do like, one new line, 2, yeah.
New line for Fizz.
Fizz, yeah.
New line 4, new line Buzz.
Yeah. And let's see, looks like you got an extra backslash there.
Oh, yes.
Yeah.
You don't need to escape Fizz.
No one escapes Fizz. Okay. Nice. Yeah, let's run that and see what happens.
Okay. Run.
Okay, expected that string, but was empty. Okay, well, and so then you want to make it pass?
So in our main method here is where we're going to be working. Just in case we want to put that back later. Okay, so I like working. Well, we just want to do the whole logic of the application.
Yeah, let's just do the whole 100. I mean,
okay. I just is I just doing like in for loop?
I think I for a for loop is it's totally makes sense.
I less than. Let's do the whole thing. I less than.
I
heard you breathe.
Equal,
so like
there you go.
Okay.
And I'm wondering why IntelliJ is like highlighting yellow. Yeah, that's interesting. Okay, you have something. Okay. And then
system.
Yeah.
Out. ln.
Yes.
In here, what's it called? Get Fizz Buzz value.
Yeah.
We don't need to do
reference
because
it's the same class. You can call a static method the same class without prefixing it with the class name. Yeah. Okay. Cool. Let's run the test. Give it a try. Nope. Let's see. Okay,
it's looking at literals like this.
Yeah, that surprises me.
Got either on
1 2 Fizz 4 Buzz, and then that's what
1 2 Fizz 4 Buzz. Yeah.
Oh, interesting. So then scroll somewhere in here. Can you make the output a little wider over here on the right?
Yeah.
I'll try to use. And is there scroll down to the bottom's gonna be huge.
That's everything. Oh,
no, the bottom over here. Click to see difference.
Yes.
Let's see what it's.
Well, the diff seems to think that it's.
Interesting. So what doesn't it write? Yeah, I wonder if it's like a character turn new line type thing. Name.
So that's /r/n or /n/. Well, I guess we try and then see.
Yeah.
Here.
Yeah, just try that.
A short.
Okay, yeah. I like that. Yeah, go for it.
So I'm gonna just.
Well, let's see if we can get it working for this one. Yeah.
Okay. Try it short.
Oh wait. Oh, that passed.
Okay.
Okay. Nice. So maybe it is that.
Okay, let's turn new line.
Yeah.
So, copy, paste, but it's not what I copied, right?
I don't know.
Let's type it. On the post to it.
Yeah.
Okay.
That was
Run.
really interesting. Okay, that passed. But is that going to work for me when I run on my Mac? Let's find out. Yeah, commit it and let's
All right.
let's try that.
This is the tag team. This
Yeah, there
is
you go.
one
Yeah,
you
yeah.
can drive. Yeah.
Yeah.
So git add git commit. Perfect.
Yeah.
So this is integration test first values. Push.
Okay. Now I'm going to take over again and see if that works for me. I don't think it won't, but I'm going to find out. We're going to apply some science, do an experiment. There you go. So now run this guy. Nope. Okay, so yeah, this is interesting. So, isn't that interesting? So, like, what can I do? Well, let's see here.
Just doing /r.
Right, yeah. So how do we make this cross-platform? Oh my gosh. Right. Actually, maybe this is a nice segue into something. So yeah, okay. So here's what I'm gonna.
It's just our integration test, right?
Well, but I mean, I want to make sure the tests run for both of us.
Yeah.
And on and we'll talk about the continuous integration server in a couple bit. What? Package what? Package logging. What's package logging? Oh, I see. Like use some sort of third-party log. Yeah, we could do that too. Maybe that would work. Yeah. Yeah. Sounds like work. Okay. Well, what can we do here? We could do a bunch of things. So, yeah.
We could just create the string using like a for, or create our test string using a for loop, using like a, right?
Well,
Yeah,
so we could do something
something.
like, yes. So let's see here. How could there are a couple of ways that I'm seeing of doing this. I'm trying to figure out which one is like the most readable. So, for instance, we could use something. We could use like string.join, right? So we could have actually. Hey, let's ask AI. Oops, one with a little prompt.
I know we just told you to go away, but
I guess I like it now. I don't want. Okay, what is this? What is it doing? That's not very useful. So okay, how can I make the code on line 14 cross-platform? Right now, it works on Windows. Let's just see what it says. Okay, that's what I was thinking. Yeah. Is that? Yeah, I guess that is right. Okay, cool. Let's see here. Insert code block a cursor. Oh, I can think about that. It also wasn't happy with that. Oh, then. Okay, so does that work for me? Okay, so basically what this is doing is, yep. Okay, that worked for me, and so let's see if it works for you. So I have to push it in.
Yeah.
Make code cross-platform. Okay, now let's see if it works for you. Share your screen so we can all so we can all see. I'm sure everybody at home is just like, oh yeah, pull first. Yeah. Are you interested in learning how to use IntelliJ to do stuff with Git?
Potentially, but not in this setting.
Not right now. Okay.
Yeah.
Not in front of anybody else. I got you.
Okay. What's that? Share. open the integration test. Okay. Rerun.
Hey, that worked for you.
Nice.
Okay.
Okay.
So I guess, that's how we can do it. I think that's a fine way of doing it, although I kind of don't like the fact that it leaks out the detail of like, oh, you need to use the line separator, but, you know, there's... Yeah, boy. I guess I'll be okay for that.
Mm-hmm.
Excellent. Cool. Thank you.
Yeah.
Okay.
Okay. Oh yeah.
I think we're good.
Yeah.
There we go. But let's do a little retrospective. So like, what was it like being up here again, and like how was it for the first time, and what did people at home think?
Yeah. Kind of similar to the last time, like approaching the integration test, also learning experience for me.
Yeah. Right.
So,
yeah. And that'd be good because you're going to have to use that for your project, right? So that's how you get code coverage for your main method.
Yeah. And then also just kind of confirming some of the things that like I knew but wanted to confirm with sort of like Java, like standard writing of Java code. So I can't think of the right word, but like for using like your for loop.
Oh, nice. Yeah.
Designing it. Yeah. Conventions. That's the word I'm thinking of. So yeah, just good confirmation for that.
Nice.
Yeah. Excellent.
Okay. Thanks, Sam.
Yeah. Thank you.
Yay, awesome. Okay. I will take control again. Yeah. Okay. Place furniture. I got it. Nice. Well, cool. Well, excellent. Okay, so I think that's good. That was about an hour of pairing. And I hope you got a feel for what it's like to pair. Right? You are in conversation with someone. You're working in small pieces. You are, leveraging test-driven development to give you feedback to find out that, hey, does your code behave the way you expect? And you learn things. And hey, also feel free to have the AI make it a trio, and so you can learn from it. And hopefully, it gives you some good advice. Excellent. Any further observations from the group about what you saw tonight, and any concerns, ideas, questions for Wednesday when we do this for real? Sweet. Okay. Oh, there you go. Excellent. Okay, well, so then that's all for pairing tonight. So then we're not done yet. People are packing up. Sorry. Oh boy. Okay. Yeah. Bar closes soon. I do want to talk about getting your money's worth here, guys. I do want to talk about Project 2. Apparently, it is that bad. Okay. Excellent. Hey, here's something that's relevant to you. Project 2. Okay, this counts towards your final grade. 7 points. Okay, so Project 1, which hopefully you're breaking ground on soon, is the training wheels project, right? It's the one where it doesn't really do much of anything. You parse the command line, you create an appointment object with information on the command line, and you print it out. And I think as someone asked, when last week when we learned about a Project 1 assignment, nothing is written to disk. It's it's really quite simple. Well, Project 2, things are getting a little bit more interesting. You're going to start writing some stuff to disk so you can persist the information that you add via the command line over multiple invocations of your program. So basically, we're extending Project 1 by adding the ability to store the contents of an appointment book in a text file. And this will give you an opportunity to work with Java's APIs for performing I/O. And so all of that is covered in the Java I/O lecture here. Please be sure to check that out. It talks all about the various APIs for manipulating text, writing text to, and reading text from, writing text to certain destinations and reading it from certain sources. So, in Project 2, you are going to work with the text dumper and text parser classes. And as a matter of fact, let me open those up. I think they're already created for you in the. Yeah, actually, let's see here. They exist in the appointment book. Yeah, here's text dumper and text parser. We have some very simple examples that show you how to get started with things. And the whole idea is that, let's make it, here's like your So let's look at text dumper first. The text dumper is a class that implements this appointment book dumper interface, and it says, I'm going to dump an appointment book instance. And so you get code like this. And the whole idea here is that it has a dump method, which will take an appointment book instance and write it to some destination, right? This is, the dump method is inherited from this appointment book dumper. And over the, let's see here, you're going to be, sorry, where is it? Yeah, in Project 3, you're going to be creating another type of appointment book dumper, but for Project 2, you're just going to do the text dumper. So the whole idea is that the text dumper converts an appointment book to a text-based format of your choosing. So part of the assignment is to come up with a format, a text format that represents all the information in your appointment book, so it can be dumped out to some destination and then read back in from that destination. The destination will be a text file in this case. So the appointment book dumper dumps the contents of an appointment book to a text file, or actually some destination, but it's going to be a text file for this project. And then the parser reads it back in again, right? So this is what you're learning to do. Take the data out of an object, put it into a file, and then read it back in again. And again, the format of the text file is completely up to you. It's part of the assignment for you to come up with a format that you can parse and that contains all of the data necessary. The interaction with those classes is driven through a main method of a class called Project 2. I recommend that you rename your Project 1 class to be Project 2 and go from there. So Project 2 has exactly the same command line as Project 1. However, there is a new option there. So there's an optional text file argument that specifies where to read and write the appointment book from. So again, you've got the required arguments like owner description, begin and end time still in 24-hour time. But now you've got this dash text file in addition to your print and your readme that will specify the location of the text file. Note that, and so what the program does is it, when you run the program, after validating that the command line is well formatted, that all the data is supplied and has a format you can deal with, it will do what it did last time. So it'll create a new appointment book. It'll add an appointment based on that, and then it will dump out the contents of the appointment book. Actually, sorry, I'll rephrase that. After it validates the command line, it will create an appointment book from using the text parser from the file if the file exists. If the file doesn't exist yet, that's perfectly fine. It'll just create a new appointment book, just like it did in Project 1, and then add the appointment to it. And then it'll dump the contents of the appointment book. So if there are any pre-existing appointments, it'll include those, and then it'll add the new one also and dump the whole thing out to the location, the file that's specified as after the dash text file option. There's a couple of reminders. Again, if the text file doesn't exist yet, that's perfectly fine. You've got to be able to bootstrap this somehow, so don't issue an error if the file doesn't exist. Note that this text file that's provided to the, or this file that's provided to the text file can be anything. It can be any valid file, so it can be, I don't know, specified from the root directory, or it can be relative to where the program is run. Really, there is no validation that you should do on the file, including the name of the file. So it doesn't have to end in .txt. Let the operating system worry about funny arguments and things like that. Yeah, no restrictions on there. And then, yeah, date and time still have the same format. They will change next time, but not for Project 2. And once again, make sure that the program exits gracefully if something's wrong. So you have all the same error checking that you did from Project 1. So please, keep your automated tests that you wrote for Project 1 working. And but also, be sure to detect that, hey, if the file can't be parsed, so the file exists and can't be parsed, that's an error. Or if the owner that's given on the command line does not match the one in the text file, that's an error also, to have a different owner name specified on the command line and in the text file. So those are the requirements of the assignment. again, what you're doing is implementing a text format for the appointment book across the text dumper and the text parser. And you are driving all that functionality via the main method and parsing the command line with a new text file option. Knowing that in Project 2 you're going to have a new option, and if you look ahead at Project 3, there's another new option after that. Be thinking about how your approach to the command line parsing in Project 1 might have to evolve to accommodate Project 2. So then, make sure that it's, or rather, if you feel, consider how rigid your command line parsing is, and and knowing that it'll have to evolve to accommodate a new option in Project 2. I know it went kind of fast there, but any initial concerns or confusion about the behavior of Project 1 and what the specification is? It's due July 23rd, which is that 2 weeks from tonight? No, 2 weeks from Wednesday. But I wanted to give you a heads up on it now, just sort of what you know that's coming, and realize that there's stuff that's starting to come fast and furious. Okay. There's a lot more details in the Java I/O lecture, but there's something that I want to call out here about these resource files. So, as you may recall from your Project 1, there's the readme.txt, and it's here in this resources directory, and this, as we saw in the, I think it's the Project 1 unit test. Yeah, nope, it's. Oops. Where'd it go? Oh no, this is the main class. Sorry. In the test for Project 1, there you go. It uses this code here to read in the resource file, and then one line at a time, and says that hey, that the contents of the README file is what I expect. This is an example of how to read how to get the README, this text of the README, from one of these resource files, and this is nice because it's just plain old, this is just plain old text. You can read it that way. You don't need to have all sorts of hard-coded in Java with strings and new lines and everything like that. There's a similar approach to working with resources in the text parser text. So here, out of the box, there are these two testing resources, which are ignore the XML. We only do that in the summer term when we have more time to do XML. But there is this valid appointment book and empty appointment book classes, files that contain some simple text. And the text parser test loads these resources as streams, and then sends them to the text parser, and then evaluates that it's able to get the owner name from that, because if you look what the parse method does, it basically says, oh, the first line of the file is the owner, and goes from there. I provide you with all of this as an example of how to write a unit test for the text parser. That doesn't actually involve writing to a file. Instead, it loads the content that's parsed from a resource. So the unit tests for text parsing can load from these resource files. One thing that past students have found confusing is the differentiation between a resource file and just a plain old file on disk. So what I hope to call out here is an explanation of the fact that for the tests, it's great to use the resource API. But for the main class, you're not reading from resources. Resources are static. They are read-only. They're bundled with the application. You want a Java I/O file there on the command line to work with it. So this is just a heads up, but read over this again once you really dive into Project 2. The thing I want to point out is that you don't use the resource API in your main method, in your main program. It's best used for, you don't use a resource API to get at the text file in your main program. Instead, you want to use other APIs from Java I/O that you can learn about in the lecture. Oh, and I guess one other thing, submit program. So if you have, if you add more test resources, which I recommend that you do, yeah, they must end in the .txt because the submit program only allows txt files, even though the program itself could conceptually accept other text files, files that may end in something. So that's project 2. Anything else I can tell you about that right now? Oh, it's fresh. Okay, then. Okay, and so that's really it for tonight. On Wednesday, it'll be the first pair programming, so please come to class. There will not be a Zoom option. I'm going to turn off the Zoom. Well, actually, I might leave the Zoom on if you want to use it to collaborate, but I'm not going to, interact with anybody on Zoom. Please be here in the classroom. If bring an HDMI adapter if you want to use one of the projectors so you can see a bigger screen. And between now and then, if you have any questions, please reach out on Slack. I'll see you then. Bye.